Hello, this is the PROKEEP Composite Mask final review. I'm Christian and I did design.
I'm Brian, and I was the analyst.
I'm Depesh and I'm the logistics.
I'm Jose and I did planning.
This is our presentation outline that our presentation will follow. Notion of design problem. The most of the masks readily available in the market are not usable. They're really expensive and they are disposable and have leakages. And most of them are not even reusable, rewashable. Introduction of design problem. The objective of ProKey composite mask is to demonstrate an airflow controlling sealant. It will be capable of providing adaptable material for different face shapes with the composite memory foam and silicone layer versus a silicone layer alone. Specifications: enough airflow for individual to receive sufficient oxygen insulation. Insulation should have the ability to form to different faces and be replaceable. Ability to change different filters. Product makes pressure different in ASTM F2 100 standard. Ability to withstand high temperature up to 80 to 90 Fahrenheit and dishwasher safe. ProKeep Composite Mask. They have like three component of the mask. The first one is mask frame. It's made up of PETZ filament material. Second is insulation barrier, which is made of composite of memory foam and silicone rubber. And three is interchangeable filter compartment. And our ceiling dimensions. Memory foam is 2 inches thick and total height of 6.125 inches and the tolerance of 1 plus minus 0.5 inches. And frame dimension, the mass frame has height of 4 inches, mass frame has width of 3.5 inches, and filter dimension of 1.2 by 1.4 inches, and tolerance height of 4 plus minus 0.5 inches. Now, Christian will talk about fabrications.
For fabricating the first prototype, we used a flash forged 3D printer. The mask frame was completed with the help of Richard King, and from our first sealant, we found that it lacked depth with a 0.4-inch thickness. We needed to create a deeper slit to hold the curves of the shell, so for prototype 2, we tried using a memory foam of 3/4 inch thickness, which was not deformable. This meant that the slit in the foam to hold the 3mm thickness of the mask shell was not there. For the final prototype, we used a 1-inch thick memory foam with a slit of 3mm with a one-hole foam crafted and applied with silicone resin, and here is our final prototype.
Product testing. 4 different masks were used for testing. The first one being pure silicone with our frame of ProKeep. The second mask was N95. Third mask was disposable mask. The fourth mask was our ProKeep composite mask. So product testing. 5 different tests were conducted. The first one was bag valve master resuscitator leak test, fog machine flow rate test, fog machine leak test, oxygen level test, dishwasher safety test. But because of time, we will only discuss 3. The first test was the BVM resuscitator leak test, which measured the differential pressure per each mass size sealant. The ASTM standard requires masks to be less than 5 and higher than 2 differential pressure. The mask with the closer to the ASTM standard was considered to have the best percentage of leakage. So as you can see from the graphs, you can see that the ProKey mask actually had a high pressure differential pressure compared to the on market ones, which had either a 5 or below. Next slide. So the next test we did was the fog machine airflow test. Using the average flow rate of someone, which is around 150 liters per minute, we used an anemometer to measure the velocity of airflow, and flow rate was calculated using Q is equal to VA. The mask with the lowest flow rate was considered the best at filtering leakage. As you can see in the graph, lower is better, as you can see from ProKeep composite mask, it is competitive with the on-market products. Next test that was conducted was the fog machine leak test results. Instead of timing the amount of time it takes for a fog to leak from each mask, we instead took a closer look at the directions of leakage of each mask. So for the pure silicone, there was an equal amount of fog being released. For the disposable mask, it was leaking from the sides, and from the N95 mask, it was leaking from the top. For the PROKEEP Composite Mask, however, it was very similar to the silicone sealant, but was even more was minimal amount of fog, as you can see. Using a research conducted by the University of Edinburgh, which was about the direction of mask leakage, they found that the leakage from the sides of the mask had the most potential to be more dangerous. In this case, for our case, it would be the disposable mask, which would be the most potentially dangerous.
For the project management, and during the 5 months, we divided our work between crafting a full prototype, the testing, the answers, and preparing the midterm presentation by finalizing materials and presentation, and working on the final presentation to complete the project. The cost for budget. The original estimated cost was around $400. The current cost for fabrication was around $50 for materials, with the 3D printer being free. The testing equipment was around $200, with the facility being free, with a total of $248.
For our conclusion, filter test data along with BVM analysis shows the PROKEEP mask seals efficiently along the edges of a face, with PROKEEP mask having a high differential pressure. The cost required for testing and building the mask were within budget. Cost of building the mask was expensive and time consuming, but overall, goal of project was met. For what we would have done differently, attaining manufacturing materials proficient in crafting deform-resistant material and researching other fabrication methods such as a 3D printed rubber could mitigate the obstacles in the way of the project and increase the scope of improving the sealant material.